Hello everyone. In this video represent another circuit synthesis problem. It is for synthesis of RC network. The impedance function is given ZRC is equal to S plus 2 times S plus 4 over S plus 3 times S plus 1. We have to apply first of all to construct the RC network. Before construct the circuit, we have to check the given function is realizable or not. For that one, we have to check some general properties of passive RLC function. I will check one by one. The first one is must be a rational function in S with real coefficient. You can see it is a function in S with real coefficient. Then first condition is satisfied. And second one is may not have also zero in the right half S plane. For that one, we have to find poles and zeros. In here, we can find poles from the denominator s equal -3 and s equal -1. These are the poles. There are two poles, and we can obtain zeros from the numerator. S is equal -2 and s equal -4. These are the zeros. Now I plot the poles and zeros in the complex S plane. There are two poles at -1 and -3 and two zeros at -2 and -4. In this complex S plane, this is the right half S plane. You can see there are no any poles or zero in the right half S plane. Then second one is satisfied. And third one is may not have multiple poles or zeros. In here, there are no any multiple zeros or poles. The third one is okay. Then may not have the degree of the numerator and denominator differing by more than 1. In here, degree of the numerator is 2 and the degree of the denominator is also 2. Then the difference is 0. Then third one also satisfied. And this is the fourth one. Fifth one is must have non-negative real part for all s equal j omega. For that one, we have to assign s equal j omega to this given impedance function. We said RC S is equal to S plus 2, S plus 4 over S plus 3, S plus 1. We have to assign S equal j omega. Then we said RC j omega is equal to j omega plus 2, j omega plus 4 over j omega plus 3, j omega plus 1. From this one, we can obtain minus omega square plus 8 plus j omega 4 plus 2 into 6. And the denominator minus omega square plus 3 plus 3 plus 1 4j omega. The denominator is a complex number. To find the real part of this function, we have to multiply both sides, both the numerator and denominator by the complex conjugate of the denominator, omega square plus 8 minus 4j omega. This is the complex conjugate of the denominator, minus omega square plus 8 minus 4j omega. Set RC j omega is equal to denominator minus omega square plus 3 squared plus 16 omega squared, and the numerator minus omega squared plus 8 into minus omega squared plus this one is 3 omega squared plus 3 plus 24 omega squared plus j omega into 6 times omega minus omega squared plus 3 minus 4 times minus omega squared plus 8. This part is imaginary part. This whole part is the imaginary. And this part is the real part of the numerator. And you can see denominator is a real number. Then according to that, must have a non-negative real part for all s equal j omega. You can see this part is non-negative. Then this one is satisfied. And the last one is must have positive and real residue for poles. For that one, we have to find the partial fraction expansion of this given function. And also first of all, we have to find the partial fraction expansion. Now I will do the partial fraction expansion. Function is s plus 2, s plus 4 over s plus 3, s plus 1. This is the function. And in here, you can see the degree of the numerator and the degree of the denominator are equal. Then we can write the partial fraction expansion like this: constant plus b into s plus 1 plus c over s plus 3. Residues are these values b and c. If the value of b and c are positive, the last property also satisfied. Now we have to find what are the values for it, a, b, and c. S squared plus 6s plus 8 is equal to a times s squared plus 4s plus 3 plus b times s plus 3 plus c times s plus 1. If s equal minus 1, 1 minus 6 plus 8 is equal to Here the value is 0 and is equal to 2b. Here the value is 3, 2b. Value of b is equal to 3 over 2. And when s equal to -3, nine minus 18 plus 8 is equal to, this one is 0, this one also 0, minus 2c. Here the value is -1 is equal to minus 2c. Value of c is equal to 1 over 2. You can see value of a, b and c are positive and real. Then last condition also satisfied. Now we have to find the value of a. For that one, I use s to the s squared values. From the left hand side, value is 1. From the right hand side, value is a. Then a is equal to 1. Then I can write partial fraction expansion. 1 plus 3 over 2 s plus 1 plus 1 over 2 s plus 3. This is the partial fraction expansion of the given impedance function. These values are Z1, Z2, small impedance value, Z3. Now we have to find what are the element represented by each and every impedance part. First, I consider the Z1, it is equal to 1. If I consider resistor with the value of R, impedance of the resistor is R and the admittance of the resistor is 1 over R. If I consider a capacitor with the value of C, impedance of the capacitor is 1 over Cs and the admittance of the capacitor is Cs. You can use these terms to obtain elements of this given impedance function. Z1 is value is equal to 1, then it will be a resistor. R1 value will be 1 ohm. Now I consider Z2, it is equal to 3 over 2 times s plus 1. For this one, I consider the admittance value y2 2s over 3 plus 2 over 3. These are small admittance value ya, yb. According to these admittance values, this one is equal to 1 over R, then it will be a resistor. There are no any S terms. R2 is equal to 3 over 2 ohm, because this one I can rewrite 1 over 3 over 2. Then I consider the YA. It is equal to a capacitor. You can see there is a S term. According to this YC, it will be a capacitor. C1 value will be 203. Then I consider the Z3 value is 1 over 2 times S plus 3. For this one also I consider the admittance value, then value will be 2s plus 6. Same as the Y2, this component will be a resistor. This one is R3, then this one, sorry, this one R2, this one R3, value is 1 over 6. Because this one I can write 1 over 1 over 6. And this element is a capacitor. C2 value will be 2 farad. And if I consider the Z2, these two elements can be represented as the parallel connected elements C1 and R2, same as Z2, Z3 also parallelly connected elements C2 and R3. Now we can draw the final circuit. Z1 is a resistor, R1 is 1 ohm. This is Z1 and second one is Z2. C1 is 2 over 3 farad capacitor and R2 is 3 over 2 ohm resistor. This will be the Z2 and the final one is parallelly connected capacitor and resistor. C2 is 2 farad and R3 is 1 over 6 ohm resistor. This one is Z3 and we can obtain the total impedance from these 2 points. ZRC is Z1, Z2 and Z3 are the relationship is plus, that means series connected. In here, the relationship is plus in admittance value. Then these two elements are connected in parallel. Then this is the final circuit of the given impedance function. I hope you all are clear about that example. Thank you.